Professor Yogendra Shastri will talk about very important topics. In fact, last year the industry experts said why that study was not done. That is the thing to do nowadays. By the way, Professor Yogendra Shastri has taught this course many times. And in fact, it is the schedule that he arrived at that we are using. We have further modified it, and Professor Yogendra Shastri knows all about this course.
So thanks a lot. So I'll take maybe 5 minutes just to tell you what we are talking about. So how many of you know what is our global carbon emission annual? I know some of you might taken my elective. I'm sure I've said that number before. So if you have already heard from me, maybe stay quiet for a while. Others who have not heard it from me, do you know what is the overall carbon emission of globally? How many kgs or tons we emit? Any guess? You have to speak louder. It's okay, I mean, it's wrong, it's fine, no problem. How many? 1 million, 2 million? How many? 3 million? 2 million? 4 million, okay. Any other? So the annual global is about 40 gigatons, okay? 40 into 10 raised to 9. That is our annual carbon emission globally. Now, what do you think is the contribution of chemical industry to that? How much percentage, let's say? Rough estimate. Again, just ballpark figure, I'm not looking for exact number. 20%? Any other number? So 20 is reasonable, you know. I just before this lecture, I was just looking at the latest data. It's about, you know, if you combine different sectors, it comes to about 15 to 20%. So you have 40 gigatons which you annually emit globally. Out of that, about 15 to 20% is because of chemical industry, which includes petrochemicals, fertilizer, cement industry, steel, specialty chemicals, everything put together, including a little bit by food industry also. I'm including everything here. So it's a very large number. And obviously, there's a lot of concern about climate change and global warming. As a result, there is a lot of emphasis on reducing the carbon emissions across different sectors. And of course, chemical industry will have to contribute. India has given a net zero target of 2070. If that has to be achieved, every sector has to contribute, including the chemical industry sector. And therefore, at least the major chemical companies now have come up with their own targets. I know some of the numbers for oil companies. Typically, so Reliance is probably the earliest one. I think they're talking about 2035. That's when they will achieve net zero. Some public sector oil and gas companies are talking about 2045, 2050, that range, and so on. So if you now have to actually reduce carbon emission, the first thing is to at least know what is your carbon emission. If you don't know what is your carbon emission and where your carbon is emitted, you cannot do anything more. You know, that is the first basic step that is required. So let me ask you another question. So that 20% that we talked about, 1/5, so let's say about 8 gigatons comes from chemical industry. What, in your opinion, is the biggest contributor? Where is that 8 gigatons coming from? Which activity in a chemical industry? Boiler, okay. What was that? Furnace, okay. Similar. Air, flare, okay, maybe. So every time you burn something, it is kind of obvious basic combustion reaction. Every time you burn something, it will generate CO2. Doesn't matter what you are burning. Even if you burn biofuel, it is going to produce CO2. Okay, so every combustion reaction will generate CO2. Now, in a chemical industry, there are several steps where you need energy, and therefore, in a chemical industry, most of the carbon emissions are because of the energy requirement. This energy could be you are burning fuel in the furnace, for example, a direct fired heater where you are burning natural gas, maybe crude oil is getting heated before it goes to the distillation column, or there are fired reactors where you have to achieve very high temperatures and you have almost like a furnace reactor. That is one source. Second, you obviously need a lot of steam. Steam requirement is huge in chemical industry, and currently almost all the steam that is generated is using some kind of fossil source, either natural gas, fuel oil, coal in some cases, and so on. Additionally, electricity is another important source of carbon emissions. It may not happen on your site, but if the electricity that we are using or the chemical industry is using is produced by burning coal, then as per the carbon footprint calculation, that is also accounted for as your carbon footprint. Okay. Roughly every kilowatt hour, every unit of electricity that we use in India, the carbon footprint is about 1 kg of CO2 equivalent. That is an average number. It will vary depending on the exact source. Now, why am I telling you all of this? Because as part of this design project, we want you to do some basic calculations for carbon footprint assessment. So you have already fairly well understood the overall set of activities that you will do as part of this project, which includes doing mass balance, flow sheet simulation, and so on. So as you go through this process, you will have a very good understanding of the reactions, the energy requirements, and so on. So you will have all the information that is available to you to do this kind of a calculation. So what we expect you to do is, once your flow sheet is developed and you have confidence on your mass balance, you should perform a first cut calculation for carbon footprint. And we have already developed some simple tools. Those who participated in the Course on Wheels activity would have already used that tool, or maybe they're going to use this tool soon. So conceptually, it is very straightforward. Wherever you are burning something, CO2 is being generated. Wherever you're using electricity, some indirect CO2 is emitted, and so on. There might be some reactions where CO2 is generated. Okay, that is also another possibility. For example, when you produce hydrogen using steam methane reforming, CO2 is a byproduct. CO2 is a product. When you have fermentation, CO2 is generated. So there is no combustion, it's actually a byproduct. So those could also be situations. So once you have good understanding of your process, you will have all those details. So what we want you to do is to do a basic calculation of carbon footprint. You will have all the information that is available to you. Very briefly, I'll tell you that there are 3 different levels of carbon footprint: scope 1, scope 2, and scope 3. So for those who are not familiar, scope 1 are direct emissions. So if you have a chemical plant, you have some boundary of your chemical plant, any CO2 that is emitted on the site is scope 1. So this includes combustion, any burning that happens, and so on. Scope 2 is emission because of electricity that you take from outside. Okay, let's say you are not big enough. Some plants will have captive power plants. So they are generating their own electricity. But many smaller scale plants may just get electricity from the grid. So the CO2 generated while producing that electricity is scope 2. Okay? And scope 3 is indirect emission related to procurement of raw material, the material that is made, the emissions during the manufacturing of let's say, catalyst, and so on. So we don't expect you to look at scope 3 because it is fairly complex, not very straightforward. But what we think is scope 1 and scope 2 calculations are straightforward, especially after you have had good understanding of the process flow sheet. So that was sort of a brief summary. I've sort of emphasized why we need to do this, what you are expected to do. Subsequently, during the semester, when you have some requirement or if you have some questions, feel free to talk to me. One of my students is also the TA for the course, so she'll be able to help you. We will also be available to help. So that is one thing. Second, Professor Mahajani talked about, that is the minimum that you are expected to do. but we also encourage you to do more. And one thing you can probably try is, now if I have to reduce the carbon emission, you do the calculation, okay, you do the carbon footprint calculation per kg of, let's say, uh, whatever product that you are producing, this is your carbon footprint. If you have to reduce it, what options do I have? Is there any technology available? Maybe there is an upcoming technology that can reduce the carbon footprint. So we would like you to explore these options to a certain extent. You may not do the calculation also for the revised process also, but at least you should know what technologies are available, what modification I can make in the process so that this carbon footprint will go down. So that will also be a good learning exercise for you. It will be a good experience for you to understand how companies will think. Now, very soon, we routinely interact with industries, and they have a large requirement for people who can think along these lines. This industry is going to pick up drastically. They will need people with basic understanding of these concepts. So it's a good opportunity for you to learn this as part of a course. So yeah, I think that's the brief summary I wanted to give.